Humanity just reached the threshold of the stars. When the results of NASA's latest propulsion experiment quietly slipped into the scientific domain, few expected what followed. It wasn't a ripple of interest, it was a detonation. After generations of chasing faster than light travel as a fantasy of science fiction, something extraordinary happened. NASA confirmed the impossible. A propulsion system capable of reaching light speed, not just approaching it. Not relativistic. Not theoretical. Actual light speed. 186,282 miles per second. The scientific and philosophical impact is beyond words. In one announcement, centuries of speculation gave way to engineering. Behind this revolution is a drive system that rewrites our understanding of motion, time, and the very nature of the universe. A coalition of NASA engineers, quantum theorists, artificial intelligence pioneers, and material scientists have done what textbooks once deemed unachievable. They built a functional prototype powered by what was long believed to be inaccessible, zero-point energy, the seething energy of empty space itself. This technology taps into the quantum fabric of the universe, using materials crafted at the atomic scale, programmable metamaterials, to harness and shape fields once only modeled in blackboards and thought experiments. No fuel tanks. No chemical engines. This system doesn't push forward through momentum, it reshapes spacetime itself. It functions on principles once locked away in the realm of speculative physics, like the Alcubierre model, which proposed compressing space ahead of a craft while expanding it behind, allowing faster-than-light travel without technically violating Einstein's speed limit. The new drive, now quietly called the light drive, makes this a reality. Instead of propelling a vehicle through space, the craft sits inside a spacetime bubble. The bubble moves. The ship stays still. Inside the bubble, physics behaves as normal, but outside? Space moves around it. The first public demonstration, though hidden behind layers of security, changed history. A prototype no bigger than a car was tested inside a reinforced chamber. Scientists hoped for a fraction of light speed, 70% at best. What they got was beyond any expectation. In a flash, the prototype vanished. No explosion. No debris. Just data. For a fraction of a second, the craft existed in a relativistic frame, then exited our reference frame entirely. It wasn't destroyed. It simply left. The data confirms it. The craft achieved light speed transition. What followed was a cascade of revelations. The iron chain of cosmic distance, what's long kept us tied to our sun, was shattered. Suddenly, Alpha Centauri, the nearest star system at over 4 light-years away, isn't unreachable. With this drive, that journey becomes a little over 4 years, from Earth's perspective, and the crew's. No time dilation. No aging paradoxes. Inside the bubble, time flows as it does on Earth. The light drive elegantly sidesteps relativity, keeping internal time intact while external space moves. But building this technology required answering the unanswerable. Harnessing quantum vacuum energy meant creating containment systems capable of withstanding impossible stressors. The solution? An adaptive energy lattice, built from materials able to respond to quantum-scale shifts in real time. Navigation posed a different challenge. Traditional systems can't function at light speed. So engineers turned to AI, not as a co-pilot, but as a predictive navigator. Using quantum entanglement, gravitational mapping, and deep spectrum data, the AI doesn't just react, it foresees. It reads distortions in space-time seconds, even minutes before they manifest. All of this has massive implications. The light drive isn't just a propulsion system. It's the gateway to the galaxy. Planets we once studied from afar could soon be visited. Entire solar systems are within reach, not in centuries but within lifetimes. For humanity, raised on tales of warp drives and hyperspace, fiction is now touching reality. But this leap comes with profound questions. What happens when Earth is no longer humanity's only home? What governance exists in interstellar space? Who controls this technology, and who decides where it's used? A new space race has begun, not for the Moon or Mars, but for the stars themselves. Governments, private industries, and alliances will compete to perfect and claim access to this technology. Beyond the politics and science, though, lies something even deeper, the shift in our identity. The first journey was uncrewed. A test, controlled, cautious, historic. A small craft, no bigger than a satellite, slid into the silence of space and vanished in an instant. There was no trail, no flash, no sonic boom. Just a ripple in the readings, a distortion in time, and then, confirmation. It had crossed the threshold. Its sensors, running on quantum coherence, continued transmitting through entangled channels. They whispered of warped geometries, of relativistic null zones, of space folding like silk in the hands of physics made real. What returned wasn't just data, it was a message: this works. A second craft followed. Then a third. Each journey braver, each return richer in knowledge. Flight paths stretched farther. Distances that once spanned centuries compressed into weeks of travel. The map of humanity's future was no longer a flat projection of Earth's surface, it was a stellar chart. And then came the inevitable question: when do we send people? Applications flooded in. Pilots, engineers, exobiologists, linguists, philosophers. Not soldiers, not conquerors, explorers. A generation raised on distant dreams now stood ready to chase them. NASA, in coordination with global space agencies, repurposed entire cities into launch academies. Mars simulators became interstellar training grounds. Moon bases became staging points. Everywhere, humanity leaned forward. The first crewed vessel was named by public vote. Odysseus, a name pulled from myth, symbolizing not just a journey of distance, but of transformation. The crew wasn't chosen for perfection, but for balance. A pilot from Nairobi. A physicist from Kyoto. A medic from Sao Paulo. A systems engineer from Berlin. A linguist from Mumbai. A cultural historian from New York. And an AI, not as an assistant, but as a full member of the crew, adaptive, sentient, trained not just in code but in context. When the light drive engaged, the skies above Earth held their breath. There was no countdown, no rocket roar. Just silence. And then, the shimmer. A ripple of space, as if reality blinked, and they were gone. Odysseus I was en route to Proxima Centauri b, a planet once blurry through telescopes, now less than 5 years away by Earth's clocks, but mere weeks to those on board. A planetary neighbor, no longer theoretical but tangible. Back home, the Earth changed. Not in a flash. But steadily. Unavoidably. Borders began to matter less. The light of a shared destiny burned brighter than flags. Old rivalries quieted, not because of peace treaties, but because of purpose. The Interstellar Coalition was formed. A union of scientists, leaders, and citizens from across Earth, bound by one goal: to step into the stars responsibly. New disciplines emerged: interstellar logistics, supply chains between systems, vacuum architecture, building structures in folded space, Lightspeed law, jurisdiction in relativistic territories, quantum cartography, navigating gravitational anomalies. A child born in this age might learn constellations not as legends but as addresses. But not always unity. Where science leads, ambition follows. Private ventures, no longer content with satellites and lunar tourism, rushed to reverse engineer the light drive. Black budget programs surfaced. Rogue launches were detected, craft departing in silence, destinations unknown. There were whispers of habitable worlds being staked like claims in the Wild West. The stars are vast, but so are human ambitions. Not all journeys were meant to return. Yet Earth itself began to shift, too. Cities reimagined themselves as nodes in a galactic network. Education transformed. Children no longer wanted to be just astronauts, they dreamed of becoming xenoanthropologists, studying life that might not even breathe. Starlight farmers, developing crops for alien suns. Exoplanet ecologists, tasked with protecting non-terrestrial biospheres. Maps in classrooms no longer ended at oceans, they expanded into nebulae. A new calendar was ratified by the coalition. The moment Odysseus I left Earth was declared, Year Zero, the dawn of the Interstellar Age. But the deepest shift was not political or technological, it was existential. We are not alone in the universe, perhaps not in biology, but certainly no longer in isolation. The night sky, once a ceiling to our world, became a portal. Religions adapted. Some saw the light drive as humanity's ascension, proof of a higher calling. Others saw it as a test, of humility, of stewardship, of restraint. New philosophies arose. New spiritualities. New kinds of awe. For the first time, humanity looked outward not just with telescopes but with intention. And so the journeys continue. And with every pulse of light, we step closer to who we were always meant to become.